So in this question here, we've got a car with initial velocity of 1 meter per second. So that's what we know at the start. So let's just, as we go along, let's write it all on this diagram. So initial velocity, 1 meter per second. And the acceleration is given as this equation here, where t is time and k is some constant. So acceleration is going in this direction. Let's say the car's going that way. So acceleration equals 3kt squared minus 2kt plus 1. And then after 3 seconds, the velocity is 10 meters per second. So that's the initial velocity. But after 3 seconds, we've got 10 meters per second. Okay, right. Now, what we want to do, our goal is to find the value of k. So that's what we need to find. Okay, so now we know we've got velocity and acceleration is what we're dealing with here. So we need the relationship between velocity and acceleration. So if I just draw a quick graph of velocity and time. So velocity on there, time always on the horizontal axis. Now if my graph looks something like this, the gradient of this graph tells me how much the car is accelerating, or whatever it is accelerating. So here's quite steep, so it's going to be accelerating quite hard. Here is quite flat, so the acceleration is going to be reduced. So what we know is that the derivative of velocity is equal to acceleration, as it's the slope that we're interested in. So the relationship between velocity and acceleration, if it's the derivative, what we know is that velocity equals the integral of acceleration. So what we could do here, we could take the integral of that with regards to t, and that will then give us what our velocity is, and then maybe we can solve for these two values here. So let's have a look. So velocity equals the integral 3kt squared minus 2kt plus 1 dt. Okay, so the integral of this with regards to t. So we've now got 1, 2, 3 terms, so we can use the sum rule for integrals. So raise the power by 1, divide by the new power. So k is not with regards to t, so that will stay. T will have the power increased by 1, so that's t cubed. And then divide by this new power. Well, we've got this multiple here, so 3 divided by 3 is 1. So we leave it as kt cubed. Next one, 2kt. Raise the power by 1 and the constant stays. So that's k and t squared. Divide now by the new power. With this 2 as a constant, we've now left with 1 again. So we've got minus kt squared. So that's that one. And now this one plus 1, integral of that with regards to t is just t. So that's what our velocity is. So that's important information we can now use. Now always when we're integrating, at the end we always have a plus c, so that's our constant of integration. Now to find that, we are given some values here. So 1 is the initial velocity, so that's the velocity at time equals 0. So if, let's just take this off the board. So at time t equals 0, we know that velocity equals 1. So here we could plug that into there. So we've got v equals kt cubed minus kt squared plus t plus c. Now when t is 0, v is 1. So let's plug that in. So v is 1, t is 0, so that disappears. T0, that disappears. T0, that disappears. So now we're left with just c. So therefore c equals 1. So now what we can do is can rewrite this as velocity equals kt cubed minus kt squared plus t plus 1. Okay, now we want to find out what the value of k is. Now when we're plugging t0, we can't do nothing to find out what k is. But we've got this information here as well. At 3 seconds, velocity is 10. So let's use that like we just did here. So t equals 3. Velocity equals 10. So now if we plug those in, hopefully we can solve for the k. Let's see what happens. So velocity is 10, so 10 equals k times 3 cubed, so that's our what we've got here. So k times 3 cubed minus k times 3 this time squared. Here we just add on t again, which is just 3, and plus 1, because that's our c. Okay, right, let's get constants on this side. So I've got 3 plus 1 here, which is 4. Bring it onto the other side here. So I now need to subtract 4. So now I've got a 6. Now I've got 3 cubed, 27. So I've got 27k. 3 squared is 9. So I've got minus 9k. So that then gives me 18k equals 6. So divide by both sides by 18, I'll get k equals 1/3. So what is the value of k? We've solved it. K equals 1/3. So we could rewrite this acceleration here, because now we know what c is. We could rewrite, where is it? It's here. So we could rewrite this as acceleration equals k is 1/3. So that just disappears to 3 times 1/3 is 1. So it's got t squared. 2kt, so it's 2/3 t plus 1. And that tells us what our acceleration is as well. Okay.